Create has actually is a database which is developed in Austria, and as you can hear from my accent, I'm not. I'm one of the few people in the team who are not Austrian. I'm German. The other guys are really Austrians, which basically means if they talk Austrian dialect, I can't understand anything. So we are supposed to speak the same language, but it's sometimes not the case. Create is not very known in the US. I guess that's as well for the late hour, and this is that not a lot of people are here. But I think it's actually a really, really cool project, open source project, database project. It actually won a TechCrunch Disruptive Startup Battlefield contest. And yeah, I'll just let me give you a little bit an overview. And yeah, so the title of the slides is Big Data from the Big Austrian Mountains. So yeah, let's go into it. So what is Create? Create is a database which was built to scale massively. It is a database which is so it's not in-memory database, which are right now very popular. It's a database which has for sure cache in memory, but where the main idea behind it is to have a database where you have persistent storage. It has very powerful search capabilities, and it actually can do very powerful data analysis. It can run very powerful data analysis in a large cluster. And currently, for example, the cluster sizes we have deployed is so we have a couple. So this is still a very young product. So there are a couple of projects we know of. So a lot of projects we don't really know of because they simply use the open source version of our product, and we don't really know what kind of scale they have. From the production systems we know, one of the bigger ones is about something like 120 nodes running on hardware, and with about 3 billion inserts per day. So that's kind of something like the scale where you can get to. So it's a really scalable database. The reason, by the way, so I always kind of mix it up or have difficulties with it. So it's kind of, when we're talking about Create, there's kind of a little strange thing. So I basically say Create is built on NoSQL technology, on the NoSQL architecture, but the database understands SQL. So this is kind of a little special case here. So we have kind of like a lot of features you will recognize from NoSQL databases, but it understands SQL, and that's why it's a NewSQL database. One of the targets of Create is to be extremely simple to operate. So it's a database which was specifically built for easy operation, and especially to attract DevOps people and developers, because you just can simply install the database by yourself, and to a certain kind of degree, most probably many dozens of nodes, you don't really need a dedicated database person for it. So you just can more or less run it by yourself. Create scales almost in linear fashion when you add new nodes, and it has the search capabilities. So basically the queries, they scale with it. You can run Create on commodity hardware if you want to do that. It will for sure scale better on basically server hardware, SSDs, a lot of CPUs, and so on. But it's actually doing very well in scaling, and you can very well scale out horizontally on commodity hardware. There's no centralized storage or whatever needed. It's basically a shared nothing architecture. Storage is all locally. And Create is extremely elastic. So basically adding new nodes or taking nodes away, this is something which doesn't really require a system administrator to add a new node or to take it away. So you just can simply stop the process, shut the server down, and Crate will figure it out by itself. Or you just start a new node, and Crate will even figure it out by itself. So it will automatically, the nodes in the cluster will detect the new node, and they will start to stream data to the new node and just give it something to work. It's very resilient. So as long as you have, so we have in Crate, we have all the good stuff like sharding, partitioning, replication. So as long as you choose a replication factor, which is basically big enough, the cluster will be extremely resilient. And even if, for example, let's say you have a replication factor of 2 and you take 2 nodes down, so then, for example, because accidentally you just actually rebooted the node, when it basically then the data will be for a while, some of the data will be not available, and then when the nodes come up again, the data will be available. So even that is just not killing the cluster. It has read after write consistency. So what that means is it's a typical NoSQL architecture where you don't really have transactions, but you just have atomic consistency. And when you actually write and create a row to the database, and you just after that immediately read, you can be 100% sure that you just get the changed row back. So that's read after write consistency. So when you look in the database solution space, then I don't know if you noticed, but there are a couple of reports every year coming out about basically new databases. There are right now most probably a couple of hundred different databases existing right now. There's a wide mix of databases and different kind of storage technologies, different kind of data models which are behind it. There's a huge variety of databases you can actually choose from, and a lot of them are as well open source like Crate. So to give you an idea where Crate is actually located, so even if Crate is based on ElasticSearch, so it's basically, I will show you later some slides. So we didn't reinvent the wheel. We just started basically and reused some other open source projects. So even if Elasticsearch is here at the documents store bucket, we see Crate specifically for Crate and cloud usage. So I'll later show you why that's the case. So our problem right now is we are really drowning in data. So there has been never so much data generated as in our time today. And at the same time, what we are doing, what do we really do with the data? So we have the problem that there's a lot of data is generated, but we are just not really able to analyze it in a proper fashion. So there's an estimation. This is, by the way, something I have to give credit to Cassandra or to DataStax. That's numbers I had actually from one of their slides. So the estimation is that there's about a zettabyte of data in our world today, which most probably is about 135 gigabytes of data for every person on this planet. So what are basically the challenges in this kind of environment? So if you look at the basically traditional data and kind of compare the properties we have here, then so in the with the traditional databases, I have most probably a data. So my database sizes are ranging from gigabytes to terabytes, while when we talk about big data, we're talking about petabytes or exabytes. Then with the traditional databases, I'm talking about the centralized database, while very clearly with petabytes of data, this is not possible anymore. So you need actually a database which is a distributed database. That's what Crate is. Then another challenge is that in the big data space, while we have in the traditional data space, we have a lot of data which is structured. We have basically our table structures, which not very often change. In the big data space, we very often have unstructured or semi-structured data, which can basically change from one day to the other, from one record basically to the other. That's as well something Crate can manage. And in the old traditional data space, we have stable data models, which can be very deep. In the big data space, that's a problem. So we are actually trying to have flat schemas, because otherwise this is not really manageable. Very often the relations we have in the traditional sense, they're actually resolved as embedded relations in the data itself. So that's how this is actually working. In the traditional data space, I have a lot of complex relationships. In the big data space, I have fewer interrelationships, so a lot of relationships are as well, they're basically embedded. Then in the big data space, I have real-time, a lot of basically I have real-time data. I have analytics I want to do, and I have search. In general, one of kind of like the patterns we have noticed in the last couple of years is, and this is something we have seen over and over again, is that a lot of people in internet scale projects, they actually use technologies. So they basically use a mix of technologies for data storage. So very often they use a relational database in combination with a document database, in combination with some search functionality they need, and then they have additionally a blob storage, or a storage basically where they store their web assets, for example. So people build different stacks here with React, Solr, Rados, or MongoDB, ElasticSearch, RedFS, CouchDB, ElasticSearch, and HDFS with Hadoop. So this is something which makes projects really complicated, because you just have different data stores, and that's basically what Crate is actually trying to do. So the target for Crate is that you can combine this kind of technologies, and that you can have a database with NoSQL capabilities, with actually a flexible data model, so kind of like in a document oriented database to store your data, with blob storage and with search in one single open source product. So that's what we're actually trying to do. So this is very quick. I want to show you how easy it is. I hope you can actually read this. So I wanted to show you how easy it is to set up Crate. So this is basically another target we have as well. So this should be the easiest database you ever actually set up. These instructions are for starting an instance on Amazon EC2. So this is here from the EC2 command line. This is starting, basically, I think this is an Ubuntu image on Amazon. You log in to your server. Then this command here is loading a shell script from the Crate servers, which is analyzing what kind of Linux distribution it has. It's just going to install. You can do that as well manually if you don't want that someone is executing, that you're executing a script which you haven't reviewed. So there are instructions on the website. So this is adding local repositories to your Linux server, and then it's just going to install Crate. At this point, I'm sorry for the color here. At this point, Crate is already installed, and you can access it from the dashboard. And when you want to start to create a couple of tables, then you need to install a basically a command line tool, which has the nice name crash. So this is actually the create shell called crash. This requires Python. When you have this, actually requires Python pip, so the Python package manager. Then you install crash. Then you can call crash, and that's actually, as I noticed, this command is missing. So it's simply the command is crash, and this is the crash command line. You connect to the local server you have installed, and at this point, you're connected to your database, and you can write, basically, you can create a table, you can insert data in your table, and you're good to go. So this is basically all what's required to install Crate and get it working. When you want to install a second server, then you basically repeat exactly the same steps here. If you are in a subnet, or if you are not in the cloud, so if you're locally in a subnet, which accepts multicast traffic, then the second node will automatically find the first node, and the database you have, or the table you have created at this point, will sync up with the second server automatically. So they find each other and they will build together a cluster. On Amazon, there's one step more required if you want to set a cluster with multiple nodes. So Amazon doesn't allow multicast messages. So we have a plugin which either allows you to use single casts, or even more elegant, you can, at the time when the EC2 instance has been created, you can give the EC2 instance a tag, and then you can define in the Crate configuration that all the servers which are running in your account, which have the same tag, are part of your cluster. So what's happening is that every couple of seconds, your server is scanning using the AWS interface to scan for other new servers with this tag, and then it automatically connects them together. To give you an impression about the syntax, so for the SQL syntax, for Crate, there are a couple of additions. So one of the things I was mentioning before is that Crate is allowing for basically semi-structured data. In semi-structured data, you can actually define so either you can define this here explicitly in, for example, doing something here like an object, which then basically has nested attributes in it. Or you can simply you just actually, for example, create a very basic database schema, and then you just simply start to insert data into it. And at the time where you start to insert data, Crate will automatically will first notice the columns, which it doesn't now. It will modify its internal structure of the table, and the table will basically learn the data you're just inserting. So it's adapting the metadata of the table structure. This is default behavior if you don't want that, because, for example, you don't want if you have false data or faulty data, that this data is creating new columns, then you can actually turn this behavior off. But the default behavior is if you insert data, then this will, Crate is going to adapt the table metadata. Also, you see here a couple of keywords which are going into sharding and partitioning. So I'm defining here how many shards I want to use, and also I'm defining on which column I just want to do the partitioning. Also, at this point, I'm defining how many replicas I want to have in my Crate cluster. So replicas here in this case mean number of replicas 2, means that on the complete cluster I have in total 3 copies of my data. And then, for example, you can simply insert data, so you can do a mass insert. So for example, one data source you can use is JSON. So if you have this kind of JSON file, then you just can simply do a copy from, and then it will insert it into the database.
So this example it says clustered into 6 shards,
Mm-hmm.
partitioned by date join.
Yeah.
So what does it mean with it? Let's say I have, how does it decide which date it will put in which shard?
So Create actually tries to figure that out by itself, and it kind of stuff like rebalances the cluster on the size of the partition. But as well, you can, for example, you can define here. You can define ranges, so you can explicitly define what is part of a partition and how the partitions are actually used.
So every partition goes into a specific shard?
So the partitions are, so all the partitions you define here are as well in all the shards.
I guess my question is,
Hmm?
what is a partition? What's the importance of a partition?
So the partition basically defines the range of the values. You just so it basically defines the bucket where the data is in. So it defines the partition.
Shard, or just so basically partitioning is not simply as a shard.
So according to what you're saying,
Mhm.
a partition doesn't map directly to one shard. It will get distributed to multi-shards anyway, right?
That's correct. Hmm? Let me actually think about it, and I'll come back to you at the end.
So this is the created term, right? The partition, or is it
It actually maps. So so because it's actually sitting on top of it, this is actually mapping to Elasticsearch. It's an Elasticsearch term, correct? So create is actually written in Java. So as Elasticsearch is written in Java, you will need to have so Java is going to be installed as part of the process. One little information here, so that's something which I noticed yesterday with installing the latest version of Create. So the latest version actually requires now Java 8. So when you install that, you need to make sure that your Linux distribution has basically Java 8. Otherwise, you will need first to install it from somewhere else manually, because then the whole installation process will be not able to get the right Java version. There are different drivers available for talking with Create for different programming languages. I'll talk a little bit later about that. These drivers talk with Create either through a REST interface, or there's a binary interface. And I think binary interface is mainly for Java clients. There's a UI with Create where you can see basically the cluster status. So basically it will tell you so it will give you an overview about all the tables in the system. It will give you an overview of where the system is regarding load, and it will also give you an overview if there's any kind of problem in the system. So for example, if there's a node down, or if there's certain kind of data, or if they are just under-replicated, then in this case it will show, and it will show as well which kind of action it's taking. There is a blob storage which you can use. So there's an interface for uploading and managing blobs. These blobs are as well so managed with, so for example, the replication settings you define in the database, they are as well used for the blobs. So they're just going to be stored according to the replication settings you have. By the way, they are not stored in Elasticsearch. So they're actually stored in the file system of the nodes. And it will just distribute, so it will actually look for the size and the available space, and then it will distribute it across the cluster. There is a plugin infrastructure which is used that you can extend the SQL queries. So it's kind of, it's not really like stored procedures, but you can, for example, define, you have something like user-defined functions, and that's something you can implement with plugins. And there are many different clients available for all the main languages, like Java, Python, Ruby, PHP, Scala, Node.js, Erlang, and as well a couple of other ones. Also, Crate runs really, really well in the cloud and as well in containerized environments. The main reason why it runs so well there is that it just does kind of stuff like the whole discovery automatically. Also, when nodes are just going up or down, so Crate basically takes care of the replication, and that the data is distributed into the new nodes. So these are a couple of features of Crate. It actually supports, I would say, about 95% of what SQL, I think it's SQL 92, is actually supporting. Additionally, it allows that you do have arrays and nested objects. So that's something I showed you with the Crate table statement. So this is, by the way, directly mapped into nested objects into Elasticsearch. Then it has internally, it has an information schema, a meta schema, which you can query, and where you can find out more information about your, so basically like other SQL-based databases, where you can find out metadata about your database schemas. And cluster and node state, this is as well something you can find in this meta information. So you can build your own little client, which is querying the cluster and finding out in what kind of state the cluster is, in case this is important for your application. And one really, really big feature is that in many cases you can reuse your OR mappers you're already using, because Crate is accepting most of the standard SQL. You can use OR mappers like, for example, Hibernate and SQL Alchemy and Active Record and PHP, PDO, and so on. You can directly use that. And if you, for example, have a project which is running already, let's say, with Postgres or with MySQL, then if you don't really use stored procedures, then in most cases it's relatively easy to move it over to Crate. So this is a brief overview of the different components on a Crate node. So basically all the nodes in a Crate cluster are exactly identical. So there is a shared nothing architecture, and all the nodes are basically equal. There's one, it's not really an exception, it's basically there's one node in the cluster which normally has a special use case. That's the so-called master node. And this master node is basically the node which is having all the cluster's metadata in it. And this master node is something which is not a single point of failure. So if this master node goes away, then the rest of the cluster does an election and elects a new master node. So this information, the meta information from the master node, is as well something which is replicated in the cluster, and which then can be replaced by a new node which is taking over this responsibility. The clients in general have the choice either to use the REST interface or to use the binary interface. Then we are just using a SQL parser. I will show that on the next slide, which is actually, so that's Presto, which is coming from Facebook. Then this piece with the analyzer and the distributed analyzer and planner, that this is again a piece from Crate. This is doing the distributed execution, and then it's just merging and collecting the data and just giving that back to the client. And for the case of the blob storage, that's working a little bit differently. So that's kind of bypassing most of this. So this is then directly going. So this is retrieving the blobs directly from the nodes. So this is an overview of the different layers, and as well what kind of technologies are used here. So the base storage layer is Lucene and ElasticSearch. So everything is basically stored there. And also on the side, we just have the block storage, which is the blob storage, which is outside of Lucene and ElasticSearch. Then this is the network layer, where we are just using Netty, and so for basically transferring the data here. Then we have the aggregation level. This is something, so you can see from the color coding here where the things are basically coming from. So this is what we have developed completely by ourselves. This is the distributed SQL, the distributed reduce, and the data transformation here. For the layer with for the querying, we're using Facebook Presto, and then this is actually calling the query planner, which is then doing the execution. Also, there is on this layer is the module for importing and exporting the data. And as clients, we just have so the Crate dashboard, then the shell, crash shell, the Crate shell, which is called Crash, and also we just have a lot of different kind of client libraries, and also Java, which is kind of a first-class citizen here because it actually uses here the binary protocol.
So does Crate directly use Lucene, or does it use it via Elasticsearch?
It actually uses directly Lucene. Yes. Mm-hmm.
I have two questions.
Mm-hmm.
Which version of Elasticsearch are you using with your latest release? And the second question is, do you support geometry and geohash?
So the current version from the latest Elasticsearch version, which right now in the last sprint was published, is using Elasticsearch, I think 2.0. That's basically brand new. Then the second one was, what was the?
The geometry fields. Do you support geometry fields? Do you support geohash aggregation and geoshape?
There actually, I know that there's some. So there are some brand new functions regarding geo location or geo data type basically in there, but I have not actually played around with it, so I'm not really sure to what kind of trickery that is supported. But this is a feature which came actually in with the latest version, so I would need to have a look and see what exactly is supported there. Yeah, so these are the technical highlights for Crate. So it's very easy to scale and to manage database. It is based on a shared nothing architecture. You can use real-time SQL. It supports environments with high availability requirements, and you just have a data store where developers have a very easy time to develop with, because it doesn't really give them a lot of restrictions. So you can very freely basically insert data into the database and manage it. So regarding scalability, so there have been in our bigger setups, we had actually up to 300,000 records inserted per second into a crate cluster. And if I remember, this was even not on hardware. So I think this was actually on an EC2 cloud deployment. Shards can be actually moved manually or automatically. So the standard settings, which actually with crate come, is that crate will actually try to optimize that by itself. So in general, data can be semi-structured, and you can use either strong SQL schemas or schemaless SQL schemas. So that's basically something which is up to your decision. If you choose to, if you basically choose to define a database schema, a table schema by yourself, or if you actually want that that crate actually auto-detects the schema. You can have nested documents. So this is basically an ElasticSearch property. And these nested fields is something you can use exactly in the SQL queries, exactly like you would use normal fields. So if you actually have nested fields, then you basically have the field name dot, the nested field dot, if there's another nested field dot, etc., etc. And as well, the same thing, if you have an array, then you just can select kind of array elements out of it. So this is directly supported with the SQL. So that's kind of an extension to the normal SQL, that you can have those nested elements there. Yeah, then the crate planner is actually that piece in crate which just tries to optimize and have an internal strategy for having the optimized queries on the crate cluster. The collect, shuffle, and reduce phases are used for data aggregation across the cluster. And for sure, crate uses a cache for internally speeding up the queries and caching. So if you have, for example, paging, to have faster access here. And crate is developed with the Java NIO interface. So basically, it uses the internal asynchronous capabilities of the NIO library in Java to execute or basically process the I/O. Yeah, a single table you can't. So you can't have. So you can have. There are no constraint support. Also, when we talk about tables and kind of stuff like single tables, there are joins. I haven't mentioned that so far. So it's actually in one of the latest versions. So there are now inner joins and as well cross joins. But for example, outer joins are not really supported. So you can have some dependencies between tables, not regarding constraints, but you can, for example, do joins, which is actually was a pretty big step. So I think it took about a year to develop. So it was quite a bigger subject. Yeah, you can. That's basically happening automatically.
So basically join operation.
Yeah. No, I meant you.
Yeah, the join is happening in the client side or Java code. It's not in the application.
No, it's happening on the servers. So the servers basically. No, it's happening on the crate level, exactly. So that's the secret sauce of crate, basically. Um, it's relatively new. I have not seen kind of like good. So there's I've played around with it, but I have not really. I don't really have a test environment where you can see a comparison between, let's say, a MySQL database joining locally versus crate actually doing that. Anyway, it's kind of a question. What is kind of like a good? How can you really test it well? Because to be fair and having kind of like good numbers, you would actually need to choose a scenario where MySQL really would have problems because of the size. So I haven't seen that yet. I hope they can publish something on the blog soon about the performance there. There are actually a couple of there are a couple of I think there are 2 blog entries right now on the Crate website, which is talking about optimizing basically performance of joins. If you want, you can have a look there. But like I said, I don't have a direct comparison between relational versus NoSQL joins. Sorry.
Yeah, so I wanted to ask, do you have any integration with Spark? Do you have any Spark connectors that can write to the crate?
No, but no, we don't.
Like joining to
I was actually sorry. I was thinking about something else. So when I was actually thinking about real-time data, so there's currently some work invested into making Crate a MySQL slave. So regarding streaming data, but not in the Spark world. I don't know, but if you give me your email address, I can basically ask. So actually, my colleagues are meeting tomorrow for some skiing in the Austrian mountains, and also they just have a week ahead of kind of like planning and so on. So unfortunately, fortunately, because I really hate the cold. So unfortunately, I'm not there, so I don't know right now what is planned, but I will be able to find out at the end of the week.
there is a Spark connector to Elasticsearch, but
Yeah, but the problem actually.
that's not going to be a good idea
Mhm.
because it's not to break the crate metadata.
You got it exactly. Yeah. So in general, kind of Elasticsearch is kind of packaged into Crate, and you can query Crate through the Elasticsearch interface, but you should not really insert or update data because that's gonna confuse the metadata layer, which is sitting on top of it. So the schema information as well, the internal information Crate actually has about it. So it's read-only, the Elasticsearch connection. Crate is licensed under Apache, under the Apache license. If you want to have a look into the source code, then you can do that. This is published, so all the source code is published under on the GitHub account. Also, if you want to have a look, so we tried actually to reuse as many open source projects we actually could to not rebuild the wheel. So if you're interested in what we are kind of using, then you can find that here. That basically said, just a couple of more words regarding database scaling with Crate. So that's one of the features we are pretty proud about. So that you just have a shared stuffing architecture. So that all the nodes are basically the same. The app containers, they by the way, they actually, so the connectors we have built here, the drivers, they are intelligent enough that when they're actually talking to a node, that the node actually will basically tell them either to talk with them or basically talk to another other node. Also, there is a mechanism built in the drivers, so in case that one of those nodes basically go away, that it actually can talk to another node. So that's in this case, the intelligence is built in the drivers. Crate runs really well on different container-based environments. One of the really good integration or tests we have done is together with CoreOS. So, for example, you can run Crate containers there with Fleet, and you just can actually push the Crate containers out with Docker and Fleet, and then manage them there and kind of scale up and down. So this is actually working really well. So in general, in all these different environments, like containership or directly with Docker or with Tutum, so we have actually built Docker containers, and we basically have tested in these environments, and this works really well. Like I said, because of Crate's capability of kind of the auto-detecting the cluster, and then when you basically scale up and down to do this all automatically. Yes.
Regarding the auto detecting the cluster, if I remember correctly, starting at ElasticSearch 2.0 or 2.1, they disabled the multicast as an option, right?
That's if that's the case, then we have a problem. Yeah, sure. So I think I mentioned that before. So if multicast doesn't work, then there are a couple of other possibilities to configure it. Yes. What is the default right now? Unicast. Okay.
And also it's not going, we know that's going to be a problem in Amazon, right?
Yeah, so
I'm wondering how the Docker images would work in the Amazon.
So like I think I mentioned it before. So for example, in Amazon you have different ways of doing it. So one way is I think you can do it with a DNS, but kind of the most elegant way of doing it is do it with tagging the instance. And I'm not sure, so I don't think that the Docker containers have been tested with ECS. There's actually a Mesos scheduler, I think, which has been written. Yeah. Yes. Yeah. That was about maybe 3/4 year ago. Yeah, there's a scheduler for that, and so it runs in Mesosphere as well. I'm not sure about Kubernetes, so not sure. I think there was something there's something built there as well, but not sure about that. It's so the easiest way is just simply search on our website. So you will find it. We had actually 2 or 3 weeks ago, I think we had a problem with the blog, and a part of the content actually was down because of a little mishap. But right now, so all the content should be up again. And so as soon as there's kind of a new thing out, a new feature out, you will find it for sure on the blog. So there's quite a lot of documentation out there. So there's it's pretty well documented. The only thing, so we have a couple of third-party, for example, drivers. They might be not as well documented, but whatever is actually maintained by Crate is actually has quite good documentation. And if not, there's in the bottom corner, there's a little chat box, and there's a real engineer sitting there, so you can actually ask them this kind of questions. And so the only thing you shouldn't do is most probably do it kind of stuff like super late in the night, because then this is kind of Austrian, so Middle or European time, so they're not gonna be in the office. But if you kind of try to chat with them in the morning, they will basically directly respond to you. So this is the crate is available as a Docker container, so you can directly use that. You can use it with Swarm. Then it's on Kinematic, so that's another place where you can actually get the container. So that's this one here. I think the projector is actually not really sharp. And also, there are a lot of different ways of a lot of different cloud platforms where you can create. So there's actually, on AWS, there's an AMI you can directly use. Also, there is a website. If you're interested, you can come to me and I can give you the address. But there's actually a CloudFormation generator. And the CloudFormation generator, you can kind of type in, I want to have, I don't know, an X large crate cluster with 10 instances, and I want to use EBS storage in this, and with 2 availability zones, and blah, blah. And then at the end, it will spit out a complete CloudFormation template. And then you can load this CloudFormation template into Amazon. And the only thing which you need to have ready at this point is your SSH key in Amazon, and everything else it will automatically orchestrate and create. So that you have security groups and all the other stuff will be created for you and configured. Azure, there are images available for GCE. There are images available, and then also for SoftLayer, there are images available. Here's a little bit different. There's some salt, basically installation procedure there. That's one of the things I haven't tried yet, so I can't tell you exactly how that's working. Crate is mainly, as you can see, popular in Europe. So we are very present there at user group meetings and conferences and so on. So in the US, we start to have right now as well. So these are kind of on our download numbers. We start to have more and more people looking into Crate. But it's, so in Europe, we have right now the most people kind of looking into Crate. If you want to play around with it, I'm also recommending there are a couple of nice examples you can try to kind of get a feeling how you can develop with Crate, how the drivers basically work. So there is on GitHub, there is a GitHub example. So I don't know if you know, but there's so the GitHub has actually opened up their so they have a quite big amount of data stored about the commits of their users to public repositories, and that's actually data you can mine. And GitHub has right now every year has kind of a data mining competition where projects are finding kind of interesting analysis of that data. And we have actually built such an analysis on Crate. There's an example you can download from GitHub, which analyzing languages, request latencies, sentiments, and so on. So that's the way the example looks. You just can, that's something you can basically reuse for your apps, and you can see how the analytics and the aggregation basically perform. So if you download the complete GitHub archive, this is going to be 100, 200 gigs of data at least. So you can see how this is actually performing, how Crate is actually performing with big data. Also, what I want to mention is Crate is, so because there's actually Elasticsearch under it, works very well with Elasticsearch tools. So for example, you can use Kibana for, in this case, these are some weblogs. And these weblogs are actually fed into Create as a SQL table. And then you just can, for example, use Kibana on the Elasticsearch interface to analyze that as a dashboard.
Is there support for specifying analyzers and different complexities that Elasticsearch has for like specific fields or like matching?
Not to my knowledge. So that might be possible that you can do that through the to the plugin interface, but I'm not 100% sure.
And then how do you said the reads, the writes are consistent?
Sorry, what is it?
The writes
Yeah.
are consistent?
The writes are consistent, yeah.
How do you guarantee consistency? I don't know if
Mm.
Elasticsearch has right?
Mm.
There is a performance penalty for doing that?
There is a performance penalty for doing that because you need to wait till basically the last of your replicas have actually written before you can actually return. I'm not sure if how this is implemented. I think this is as well a Create thing as far as I know. I just only know that you can tune it, and you, for example, you can disable read after write consistency, but it's heavily recommended to use that. Okay, that's all I had as slides. Questions?
So, Fred also supports blobs, so, right?
Mm-hmm.
So these blobs will just distribute on different nodes, just load to that node.
Correct. So when you download a blob, Create will automatically, so you don't need to know about which node is actually located. So this will be handled internally by Create.
It's not sharded.
It's not sharded, that's correct. It's basically, it's a file which is in, but it's actually, so it's replicated. Mm. And you will be, for example, if this is kind of the next question, so if you, so it will not, for example, if you download it, if you have a replication factor, it will only download it from one node. So it will not go to the multiple nodes and kind of stream it at the same time. So it will be only downloaded from one. Okay, then thank you very much. And so I'm also in the exhibition hall. Forgot right now which number the booth is. It's something like 300 something. So whenever you have time or want to ask some more questions, please come over. So I'll be there tomorrow at the normal hours. Cool. Thank you very much.